Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I kind of like to welcome our members and also request us to engage us in the comment section and also subscribe and ring that notification bell for various updates on different discussions in mathematics and sciences. Now in today's discussion, I'm going to look at production of halogens. And this is going to be a general discussion which basically is going to be emphasizing on the summary of obtaining various elements of the group 7, which we had generally classified as halogens. Now, in this particular case, I had given some of the, or mentioned some of the discussions concerning the discovery and some isolation of the individual elements. But of course, I'm going to give them in a summary form so that in case we come across them in some of our discussions, so we're going to be appreciating the same. Now we have said the first member, which is fluorine, and fluorine of course is going to be a gas at room temperature, and this was first isolated or prepared by Henry Moissan. So we're going to take this French scientist who was given the name, or who was going by the name Henry Moissan, who first of course prepared this specific element of fluorine. And of course, this was done by using, of course, the fluorine, using the electrolysis as a method of production. And perhaps we can give this one in terms of an example or a question so that we are able to appreciate that one. So in case we give this one, we can use an example of a hydrogen fluoride, and I'm going to have this one given as such. So we're going to have a general equation for this one whereby there is a production of fluorine and hydrogen gas given as such. So in this particular case, we're going to see that this general reaction can be given in terms of the individual reactions that are going to appear. So they said that this is going to be obtained through the process of electrolysis. And in this case, therefore, we're going to have both reactions at the cathode and anode, so that we can see how these individual gases are going to be produced. So the first reaction, which is going to be given at the basically the cathode, we're going to have hydrogen being reduced. So we're going to have a reduction of hydrogen, which is going to occur at the cathode, and then we are going to have these two electrons, and therefore this is going to lead to the production of that hydrogen gas given as such. So this is going to be a reduction process, so therefore we are going to expect hydrogen to be reduced from its ionic form into this specific gas which we have given in this specific equation. And then we're going to have a reaction at the anode where the fluoride ions are going to be as well oxidized. And these are going to be given in terms of the fluorine, and then we're going to have electrons being given as such, and this is going to be an oxidation process taking place at the anode. So we're going to have this one given as such. So in terms of an example, this is how we can illustrate this specific process, which of course is going to be one of the essential ways, or of course the fundamental way of obtaining this element of fluorine that was discovered by Henry Moissan. And the second one is going to be chlorine. We shall look at one of the simple ways in which this specific element is going to be obtained. Now, they said that these elements are going to be appearing in diachronic form, so that's why I'm giving them in this specific order. But of course, we had said that this element basically is going to be indicated on the periodic table as a single atom given as such, but they are going to exist in their diachronic form as Cl2 given as such. So chlorine is obtained from sodium chloride, and this is through the process of electrolysis. So we're going to have this aqueous sodium chloride being or undergoing, of course, this specific process of electrolysis in order to obtain this particular form, the chronic form of the element of chlorine. And this process, of course, was discovered, or the element was first isolated by Sichel. I hope my pronunciation is correct. So this is Sichel, and this was done in the year 1774. It's good to give that timeline in case there are other developments that are going to proceed or a subsequent development, then therefore we're going to mention them somewhere later. So this, of course, was first isolated by this Swedish individual by the name Sichel, and of course we're going to see that that was done through the process of electrolysis as well. Now this is going to also have a general equation whereby we're going to have the chloride, of course, ions. We had said that these specific elements are going to be appearing in terms of chloride, bromide, and iodide forms of their specific elements. So we're going to have this one undergoing a process of reduction, of course, and we're going to have the OH, of course, ions being produced. And there's going to be addition of chlorine. In addition to chlorine, there's going to be a production of hydrogen gas being given as such. And of course, that's going to be a general reaction for the production of this specific chlorine from the sodium chloride aqueous, which I've given in this specific case. And of course, we shall look at bromine as well. Now, bromine, apart from the two which we have given for basically fluorine, which was a gas, and chlorine, bromine is going to be a liquid at room temperature. So it's going to be extracted from the seawater, and it occurs in these specific concentrations of approximately. So this is obtained from seawater, and this is appearing in concentration of over 70 parts per million in this seawater, where it occurs in concentrations of this specific case, or in terms of brine solution, which we are going to see. Now, in this particular case, the bromine in brine solution, this solution is going to be adjusted to a pH of around 3.5. And in this case, there's going to be also an introduction of a chlorine gas, which is going to be introduced to this brine solution that is containing a bromine. And this is going to lead to the, of course, bromine, the bromine ions present in this specific brine are going to be oxidized to bromine. So therefore, this is going to be given in terms of the bromide molecules being oxidized into bromine liquid being given as such. So in this case, I said that basically the introduction of this one is going to be oxidizing this, so therefore they are going to be reduced, and we're going to expect the chloride, of course, the chloride ions being part of the product in this particular case, and therefore I can basically give just an elaborate equation for this particular reaction, whereby we're going to have the chlorine gas reacting with the bromide ions given as such, and this is going to lead to the oxidation of the bromide ions, and therefore we're going to have this bromine, and then we're going to have the two chloride ions given as such. So in this case, we have said this one, so this is going to be aqueous, and I've said that this one is going to be occurring after an adjustment of a pH to 3.5, and then it's going to be oxidized by this specific, of course, chlorine gas. Now, there are various ways in which we are going to obtain different compounds, and of course, this bromine, of course, we had given it, we are not given it a context, so this was isolated as well by Ballard, and of course, that was around 1826 given as such. So our next element, which is of course the element of iodine. Iodine is going to appear in small quantities from plants such as seaweeds, and of course an abundant source of iodine apart from the seaweed is going to be this particular element compound, which we are going to give. It's going to be a compound of sodium, so we are going to have this one appearing in seaweeds. Basically, this is not a compound, right? So we're going to see that this is going to be one of the sources of iodine is going to be seaweed, and next we shall have this particular compound of sodium also being a chief source of large quantities of iodine. Now, this one can be found naturally in deposits, and especially in the country of Chile, or Chad, if we may have that one as such. This is going to appear in the natural setup in the country of Chile as a deposit in that specific form. Now, there are various other uses which we have mentioned, of course, for halogen compounds, but I can mention a few. For instance, in the production of what we refer to as plastic Teflon. This is basically a polytetrafluoroethylene, which is going to be given in terms of plastic Teflon, which is going to find some of the applications in our day-to-day lives. And of course, fluorine is used to make chlorofluorocarbons, and of course, the hydrochlorofluorocarbons, which of course we have mentioned in one way or another in our environmental studies. So in this particular case, then therefore we are going to see that apart from other uses, these are some of the uses which we are going to come across, and particularly elements in terms of their specific sources, historical context around which these specific elements were either isolated, discovered, or perhaps found. So that is it for now, guys. Kindly check our description boxes for various links of other videos, and also engage us in the comment section and subscribe for more details on discussions in sciences and mathematics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.